Welcome, everybody. This is Deep Dive, What's Wrong with Fire Safe Plant Lists. Our presenter today is Stephen Swain, Environmental Horticulture Advisor with UC Cooperative Extension, Marin, and Sonoma counties. My name is Carrie, and I'm the Educational Outreach and Communications Lead with the Center for Environmental Inquiry with Sonoma State University, and I will be your host today. So do let me know in the chat or even speak up if you need, if there's anything that I can help with, especially technology. Now, our public events are usually done at our preserves, but we've gone virtual since the start of the pandemic, and we are slowly easing back into a hybrid model with all our fall events still virtual, but our hikes and our training sessions in person at Osborne Preserves. It has been so wonderful having people join across the country and indeed sometimes across the globe. So we are excited to help you connect to nature and learn how you can make a difference even during this pandemic. The first thing I'm going to ask everybody to do is please take a moment to type your full name into the chat box. This is our sign-in sheet for the day because Zoom handles do not always match your real name, and we want to see who got here today. And it's also good practice using the chat. You can always make it a private message to me if you don't want it to be public. Before the presentation, I want to tell you a little bit about what the Center for Environmental Inquiry is and how we can be a resource to you, no matter who you are. The center manages Fairfield Osborne Preserve, which encompasses 450 acres on Sonoma Mountain, as well as Galbraith Preserve, 3,670 acres in Yorkville, Mendocino County. Pre-pandemic, we held those public events on site, and we want to acknowledge, honor, and make visible that our preserves are ancestral lands of Native peoples. And we encourage you to learn more at cei.sonoma.edu. What we do at the center is mobilize faculty, students, and community to solve complex environmental challenges, turning education into action. We invite you to join our diverse community of learners and problem solvers, no matter your background or connection to the university, because all sectors of society and all parts of the community have to get involved if we're going to be successful at addressing these things. We want you to leave today with a better understanding of our connection with the environment and skills that lead to sustainable solutions. There are many ways to get involved. We have research you can engage in, take our naturalist or land management training programs, learn about the virtual field collaboration for undergraduate classes. There's internships and student jobs, access data, lead events like these if you're an expert in something, partner with us on projects, or help create more programs by donating, since they are funded completely by the generous support of donors. And do come to our Saturday hikes starting October 16th. We're so happy to have them back. Just show up at Osborne Preserve at 10 a.m. So thank you for joining today. Please just know that each of you has a role to play, and I hope that you will choose to get environmentally ready with us as we tackle the greatest environmental challenges in history. Today, we are going to focus in on a pretty hot topic in light of increasing wildfires and the public's desire to mitigate impacts. Stephen Swain is going to present for about 45 or 50 minutes. We'll have just a few minutes for questions. You can type things in the chat as you go along if we'd like. We do have a hard stop at 1 p.m., unfortunately. So we're going to get going real quick here. Feel free to email me after the event for any follow-up. I'm putting my email in the chat. It's also the same that you got your confirmation email from, and hopefully all of you also got a reminder just a few minutes ago. With that, we have your audio turned off, your video turned on, but feel free to fiddle with that as you'd like, but please keep yourself muted if there's any background noise. I'm excited now to turn it over to Stephen.
Thanks. I hope everybody can hear me. We've been having a little, so the reason I have my face right in the screen here is because my microphone has been acting up. Can you hear me okay? Yes, sort of? Okay, good, close enough. And I'm just gonna go right into this. Okay, so I wanna start with a little bit of context to help us with how does this fit into the bigger picture. Regardless of whether we're homeowners, fire department members, land managers, or environmentalists, we all have, I know it doesn't always seem like it, but we all share an awful lot of our goals. We all want to live in a place where we can sleep at night. We don't have to worry about whether we're going to burn in our beds, kind of thing. We also want to have healthy forests We want to be able to have clean water. There are a lot of things we all share. We all pretty much agree that forests need management and fire belongs back on the landscape because that's what California's landscape has evolved with. So there's a lot of things that we all pretty much share. That doesn't mean there aren't places, the devil's in the details when we start getting into how do we make this all work though. So, I mean, today we're going to talk about some things where we don't necessarily agree. I don't want to hopefully get this all hung up on things. I'm just trying to point out in doing this that there are some things that are pretty well established that have good science behind them. And there are other things that maybe aren't so well established, but you'd never know that from looking at these lists, at least not until you start reading about 6 of them and you discover that they don't all match on what they say you should be doing or what plants are where. So we're going to get a little bit into, where did these lists come from and why? And I don't want to have this hang up too much. I mean, if you're going to run across cities that have lists and things like that, and it's important to understand where they come from and why you should maybe take these things with a grain of salt. That doesn't necessarily mean they're untrue. So we'll go into we'll get into that. Oh, sorry, wrong thing. Okay, so I was hired into this position in 2007. I'm a farm advisor, so I'm the bottom of an academic ladder. I've got a publisher parish job, if you will. That means I have to be familiar with the literature. I am not was not trained as a fire ecologist, but what a farm advisor originally did was they took research-based information and they made it available to farmers so that the farmers could make their operations more efficient and profitable and provide more food for the people of a growing country. Now that there's internet, most people are not lacking for information. And my job has morphed a little bit into, in fact, we all have access to huge amounts of information. My job is now morphed in a little bit into being like a goalie, sort of talking about what's really backed by science and what isn't. And I spend an awful lot of my time slaying popular untruths, like you can kill gophers with chewing up juicy fruit gum and throwing it down their hole. It doesn't work. But one of the first things I was tasked with when I was hired was updating this paper you see right here, written by my predecessor in this job and a local fire ecologist. And the complaints were with this document that there weren't enough plants in it. It covered a couple of hundred plants, and there were a lot more plants that people were trying to plant in the landscape, and nobody had any idea whether they were fire prone or fire resistant, that kind of thing. And they thought, it was published almost 10 years before I was hired, and they were like, has anything occurred in science that this doesn't include? And this was driven by the local fire departments, and I'll get more into that a little bit later in the talk. And so I set about doing this. This was one of the first things I was supposed to do, so I did it. And my first question was, where did the data come from? And when we look at where the data come from, we discovered there wasn't a bibliography. And that's kind of odd on a science paper to not have a bibliography. So why did it not have a bibliography? That's the question. Well, I started looking for other lists to get their bibliographies and figure out what they were based on. And it turns out there were no bibliographies for most of the lists that I could source around California. Where there were bibliographies, they simply referred to other lists that didn't have bibliographies. And that even made me worry more because it was starting to look like there was no data at all. Furthermore, when you started looking at the lists, they were often contradictory for things like coast live oak, which some people considered fire prone because it was a California native and therefore has evolved with fire. So people thought, if it's evolved with fire, we don't want that in our landscape. We want things that, haven't evolved with fire. And especially for things like Douglas fir. Now, Douglas fir is an interesting case because if you have a young Douglas fir, say a tree that's 6 or 8 feet high or 10 feet high, it tends to be filled with a lot of dead twigs, and it has a canopy that tends to be very close to the ground. No surprise there, the tree's only 10 feet tall. So a young tree, if a low ground fire comes in, tends to ignite relatively easily, burn fairly intensely, and it's basically a little torch. So that's why a lot of people have it on the fire prone side. On the other hand, a mature Douglas fir has bark that is several inches thick. And often the branches that do die and the mature Douglas fir tend to be large and heavy, and so they'll snap out of the canopy. That canopy is self-cleaning. And the crown often doesn't start until you're about 40, till it's about 40 feet above grade, because the tree can be 220 feet tall. So in that case, a Douglas fir is fairly fire resistant. It's going to be very difficult for anything to get into the canopy. The canopy self-cleans, and it can't light the trunk on fire because the trunk is huge and covered with thick bark. So one tree, one species, very different fire behavior depending upon what life stage it's in. So those were some of the problems that we were dealing with. Now, I'm going to pick on the University of Idaho here. They didn't do anything all that different than what other people did. They just put it into a general category. So here we have some general categories that they sat down and they said succulents are more fire resistant than ground covers, which are more fire resistant than turf, and so forth, all the way down to the most fire prone, which were grasses and conifers, which they say were basically less fire resistant. That's all fine and dandy. So what happens when we try to take a relatively common California plant, Festuca idahoensis, California fescue, and put it into this category? It's a grass. So obviously it's pretty clearly fire prone, except it's a perennial grass. So now we have two places it can fit into. And if you mow it and you water it, it becomes turf. So now, depending upon how this is cared for, it can fit into one of three different categories just on this one fairly simplified thing. And this kind of gets to the point. They're labeling it as plant types, but honestly, your plant type can change just depending upon how you take care of it. And that's where ultimately most of this talk is going, is that plant species is kind of irrelevant for most of this stuff. Okay. And so one of the most obviously, we would sit down and say, well, it's pretty clear that conifers are the most fire prone. That's what it has listed here. So how does this relate to fire in California? Here's a picture of Paradise after the fire. These were houses that all burned. They are surrounded by conifers. Clearly, the conifers caught those houses on fire, right? No. Those conifers are all green and still alive. Very few of them burned. So what's wrong with this picture? Why do we have the most fire-prone plants in here and a really severe fire, and all the houses are gone and the conifers are still here and green? Now, maybe you'll sit down and say, Steve, you just cherry picked that one picture of this one freak occurrence that, doesn't really happen all the time. So I will say, okay, then let's explain this one. This one was on Fire Safe Marin's cover page. This was their case in point. What do you see here? This is a fire that occurred down in San Diego. You see houses that burned surrounded by a eucalyptus forest. That's what that is. And they're blue gums, I believe. Hard to tell exactly from here, but they look like blue gums. And there's conifers in the front yards. There's palms in the front yards. There's a number of different things that are in the front yards. All these houses burned, and yet not only did the forest not set them on fire, the houses, even though they burned so fiercely that you're not seeing much of anything left standing, and those ukes are not touched. I would submit that if ukes have legal standing, they could sue for libel. So something to think about. Okay, so maybe this is just another freak one. So maybe we have one more. Okay, here's different fire, different town, same situation. So I don't want to beat, a dead horse. You guys have the idea from what we're talking about now. If these conifers are so dangerous, why is it that they're not actually catching any of these houses on fire? In fact, it's the houses that are catching the conifers on fire. Okay, so there are a lot of lists out there, and some lists, notably the one I have up here in pictured, Defensible Space Landscaping in the Urban Wildland Interface, has a bibliography, and it's published by the University of California Forest Products Laboratory, or prepared by, not really published by. It's a pre-publication copy. It was never officially published in any sense. A lot of people think this is a scientific study because it's got the University of California's name on it. It's got Cal Fire's, well, at this point in time, it was CDF's fire, the California Fire Marshal, and the Federal Emergency Management Agency. This looks like science. It's got a bibliography, the whole 9 yards, and it ranks plants in terms of how many fire safe plant lists have them a given plant in their safe or unsafe category. But what this is it's not a public, it's not representing science. It's just a publication that all of the participants were supposed to read before the meeting so they understood the state of science going into a meeting. So it's a meeting document, essentially. So it's published by Steve Quarles, Scott Stevens, Frank Beal, and some other people. I called Scott Stevens to ask him about this. And that's basically what he said. He said this was not meant for, yes, you can get access to this public. It was made using public dollars, but it's not a science paper. It's a meeting document. Therefore, though it looks like it's a science, it's not. So, and you'll find this quoted as being, peer-reviewed, published, so forth, that kind of stuff. It's not. And in fact, Fire Safe Diablo's plant list, the one that most people point to as being the most authoritative, is basically just this paper put onto a web page. Next slide. If it will advance, it is not advancing all of a sudden. Let's try. There we go. Okay, so claims made for these lists. Let's go into these claims a little bit. One is, in particular, this plant list in particular, the one that was published in Marin, was claimed, the authors said it was scientifically based, and they said it was peer reviewed, and there were other, of course, papers that were assumed to be like the one we just discussed. And that's the same thing that a lot of people say about the Fire Safe Diablo website. Let's see if we can get this to go. Yes. Okay. So, and that Fire Safe Diablo, as I mentioned, is based on this. Okay. So, what does science-based mean? It means that it is replicable in the sense that can somebody studying this get the same results by doing the same thing that the person did to generate that first list? That means that list has to have a materials and methods section so you know what they did and how they did it, so you can generate the same list, because maybe you've got different plants and you want to follow the same procedure and see whether they're fire safe or fire prone. There was no materials and methods on any of these papers, not even the pre-meeting document that we discussed earlier. The other one is it replicated? So that means basically, did you do the process more than once for each plant that you evaluated, so you know what the variability for that plant is? If you got a number, where I'm just picking a number, and it says your flammability was 10 in whatever numbers you're using, when you did it the second time, did you get 12, and the third time you got 8, and it was all pretty closely around 10? Or was the first one 10 and the second one was 35 and the third one after that was 20? There's a huge amount of variability, and it's important for us to understand what the variability in this is, to know just when we say something fits into this category, how well does it fit into that category? Finally, is it controlled? Can we rule out other explanations? The reason I have this particular image up here is because this was back in the day when science was people were just figuring out how to do science. A good scientist, ordinarily, John Baptiste von Helmont, figured out that he could spontaneously generate mice, because at the time, spontaneous generation was a credible way that people thought you might be able to create things just by doing it. So he took a dirty shirt and he took a handful of wheat, wrapped it up in the dirty shirt, left it in the floor for 21 days, and he was able to generate mice, and he was able to do it over and over and over again. Every time he took wheat, wrapped it in a dirty shirt, and threw it in the corner, he was able to generate mice. every time. And this is where controls come from, right? You have to be able to eliminate the possibility of mice coming in from the outside if you want to say they spontaneously generate from wheat and a dirty shirt. So controls are really important. So there are positive and negative controls used in experiments. Currently, no fire-resistant plant list meets all of these criteria. Let's talk about what has been done instead of what hasn't. Oh, and then the other thing, the peer review process. I want to just breeze over this really. This is a formal, anonymous process aimed at ensuring quality publication. It does not mean you got 3 of your buddies to read over the publication and say, hey, does this sound right to you? That's not peer reviewed. Whether something is peer reviewed or not is when you have somebody else who's considered an expert in the field that you don't know and has no reviews this paper, reads it, and agrees that the assumptions that you made are the correct assumptions. For instance, what would those assumptions be? Well, one of the ways we're dealing with this is, one of the big questions still facing us is, what's the most important thing to evaluate when looking at flammability of a plant? Is it time to ignition that's the most important thing, or is it the raw amount of heat produced, or is it some combination of time to ignition and then the amount of time it burns versus the amount of heat it produces, and how many kilograms of plant material and what form does that plant material have to be in to properly assess it? Does it have to be dry? Does it have to be wet? All these other questions. And if you make certain assumptions, you get certain answers. If you make other certain assumptions, you get other answers. So we'll talk about that in just a second too. So what has been done? Well, a bunch of guys that are not formally trained scientists at Las Politas, they're nurserymen, and they raise native plants for people to put back in the California landscape. And when first fire-prone plant lists came out, depending upon the way you're looking at it, a lot of them said that native plants were not what you wanted to landscape with because they're fire adapted, so a bunch of them burn really readily. And so one of the things, the rubrics that was being thrown around at the time was that if plants have volatile oils or fuzzy leaves, or they're white, the leaves are white or grayish in color, those are all things that are sort of saying it's adapted to a hot, dry environment, and these plants are more prone to burn. So they took a plant that has volatile oils, that has fuzzy leaves, and that it has a whitish appearance. This is a native sage, and they decided to test it. And they tested it under drought conditions. They let it dry down. And what they found was that even if you put a blowtorch to this plant, it didn't burn. And the reason it was on these lists was because people just assumed that, well, it was going to burn if it was like that. But it turns out nobody had actually tested the plant to figure out whether it did. It was really hard to ignite. If you did get it to ignite, you got very short flame duration and very low heat intensity out of it. Now, I put a question mark after real science here because it was not replicated well. And I'm not trying to be critical of the guys at Las Politas. They did a good job of showing that basically a bunch of the assumptions people had been parroting that we don't even know where they came from necessarily, other than people thought that native plants would burn better. They were wrong. At least when you did this, they did a whole bunch of different plants. I only picked one out, and I don't want to spend time going through every single plant. We'll use up all of our time. Another person came through, and this is referenced at the end of the paper. At the end of the this presentation, I have references, and Terry has a copy of that. We can make that available to you if you want to see the references. But Frank Beal and Etlinger and Weiss did some calorimetry studies on like 2 kilograms of plant material that they put in. Now, what form that plant material, how dry, those were some of the questions that they dealt with in trying to assess this, because they were trying to put some real numbers on different plants that we find in the California landscape. And they look at loss of biomass over time, and they were common plants in the fire-prone areas. And I got a link to it. But what they came away from, even after they finished this first round of experiments, is they were asking themselves, what is it that we really care about? Because they weren't sure that what they tested was really what was important. What might have been more important here, instead of how much heat is produced, is how easily do plants ignite? How much of a threat are they near your house? These are the results they got. And these are comparing dry wood to green wood. And the solid lines are the dry wood, and you can see they released a lot of heat very quickly, and then they released low amounts of heat as the coals burned after that. Whereas the green wood took you had to put it in there for a long time and subject it to heat for a long time before it would ignite. When it did ignite, it released a lot less heat and it went down. And this just tells us something that's kind of intuitively obvious. Even for plants in the thing, if they're drought stressed or they're dried, they're going to burn much more intensely than if they're wet. And this comes back to that same kind of question is, okay, is it really the plant species that matters, or is it how we take care of it that matters? So the fire safe marine plant list. Plant list based on what burned in the 1991 Oakland fire. So these guys, the authors of this paper, walked through the Oakland fire and they looked at correlations between housing losses and the plants that were burned that were next to them. The problem is correlation is not causation. As we have already seen, when houses burn, they set the plants around them on fire. So how do this correlation thing of saying, oh, these plants were near these houses and the houses burned, so therefore the plants are dangerous? Maybe it's not that the plants are dangerous. Maybe it's just showing you that when houses burn, plants catch on fire and the house is dangerous. That's a little bit of a problem. You're talking about correlation. You're not talking about causation. Here's one of the pictures from that fire. And as you can see, we have a lot of plants. They're saying, oh, these conifers are all dangerous. Here's a plant, here's a house that survived the fire. It is surrounded by conifers. What is it not surrounded by? It is not surrounded by other houses. You've got a road on two sides, you've got an empty lot on the other side, you've got a driveway on the back side. The main reason this house likely survived is because it wasn't next to another house that was burned. That's what did this. And yet we were walking through here trying to figure out what plants were going through. So I'm just trying to say that I'm not trying to castigate anybody here. I'm just trying to say we have to be careful about the assumptions we make going into a study. That's what peer review is all about. And this is, again, more of the same that we saw in the San Diego fire. Now, a lot of other things, and this is famous. You'll be able to find this image on YouTube. It's a bunch of, it happened in, I believe, in the East Bay. There was a power pole and near a Italian cypress, and the Italian cypress ends up going up in flames. And people cite this as Italian cypresses are dangerous because of how intensely they burn. And, you know, I'm not arguing that that's not an intense burn. That is pretty frightening right there. But and so, you know, Italian cypress is now a favorite of the people, and maybe justifiably so. I'm not of people saying you probably don't want this around your house. Well, if that's true, one of our favorite trees is coast live oak. And here's a picture of coast live oak burning. And it's also really intense. And yet one of these is on a fire safe plant or a fire resistant plant list, and the other one's on a fire prone plant list. And so you can't use individual testimonial type things like here's a picture of a really intensely burning tree. That doesn't mean that that tree is always going to be like that. These trees could be very drought stressed, and in an urban setting, they could be adequately watered. The other trees were right next to power lines. Maybe we don't want tall trees that build up things right under power lines. Anyway, going on from there. So fire safe plants. This is a little bit of a misnomer. And these are all things that were taken remotely. So this is the pictures I'm going to show you now are pictures I took off of Reedley Road. So it's nice to talk about these things that happened in Oakland or happened in Southern California. Now we're going to get real and keep it to what we're talking about here. While none of the fire safe plant lists meet the criteria for being science-based, and they're often contradictory, we want to know a little bit more about how they're going to perform here. So in these instances, we have eucalyptus trees that were right next to houses, and the houses ended up burning. And most of the lists, since they're based on correlation or observed burning, they're not really science. So let's go. So these eucalyptus trees did not burn to the core. They never really caught on fire. They got scorched, but as evidence that they never really caught on fire, the cambium tissues, the water conducting tissues, are still intact on these eucs. So while they got scorched, they didn't really burn. That means it wasn't the ukes that were setting anything else on fire going in here. These ukes are all still alive, and they are, well, actually one or two of them have been removed, but it wasn't because they died from this. But the houses were gone long before. Why is this showing up twice? Similarly, people say, oh, you know, palms with dried fronds you need to worry about. There was a house at the top of this hill. It's gone now. And there are palms with fronds. The fronds never even ignited on these palms, and yet the house is gone. So how much of a threat were those palms to this house? Again, these kind of correlations that people have made, they don't always work. Now, this is a bit glib, maybe, but here I've got a graph, and what it shows is the per capita consumption of mozzarella cheese in the United States and civil engineering doctorates awarded in the United States. Now, there is a pretty direct correlation between 2000 and 2009 with the amount of mozzarella cheese consumed and the number of civil engineering doctorates. So logically, if this kind of correlation exists, we should be force feeding our PhD students mozzarella cheese because they'll have a better shot at getting they're finishing their degree as a result, right? I mean, that's where we're going with this kind of stuff. And there isn't, I mean, maybe there is a real correlation there. Maybe the guys who are going for, and gals who are going for civil engineering PhDs eat a lot of pizza while they're studying. I mean, that might be, but it's not that you can, just because they're correlated doesn't mean that eating more mozzarella cheese is going to, correlation is not causation. You know, it's just a relationship. We can make a similar graph for, what is it? The number of the rate of piracy on the high seas and global warming. As global warming increases, piracy decreases. It's a pretty straightforward relationship, and yet, you know, if we should be seeing very low levels of piracy today, and we do because of global warming. It's a, you know, anyway, I know that's silly. Okay, so, you know, what about, am I saying that all, that we know nothing about fire safe plant lists and that all plants that, you know, that we can't say anything? And that's not what I'm saying, okay? This is a bell curve that I'm showing here in this graph. And when people tend to notice differences on their own, you tend to notice it when you get about more than 2 standard deviations from the mean. Now that's statistically talking, but all I'm trying to say is what most people can accurately pick out is stuff at the tail end of these curves, these little outside edges, these little triangular-like corners. Everything that's in the middle of this curve, people can't tell the difference because they're too close to each other. It's just too hard to tell it apart. So it is true that Swiss chard and petunias don't burn nearly as well as dry grasses do. But Swiss chard and petunias are out on this 2% edge. And if we restrict ourselves to just landscaping with Swiss chard and petunias to keep our houses fire safe, we're going to be losing out on a lot of valuable environmental benefits that come with having some of these other plants in the landscape. And it's not just about fire safety. It is about habitat, it's about global warming, and we can touch on those. We don't have enough time to go into them all today. I mean, because we can talk about almost any one of these things forever. So I will touch on those very briefly in a moment. I just want to get back to, you know, this one list I'm using as the example for what I'm talking about. Many of the other lists fit into this category. A lot of the other lists, particularly San Luis Obispo's, had a much, how shall we say, humbler people who simply said, yeah, I made this up. I just walked out onto my nursery because people wanted a fire safe plant list tomorrow. So I did the best I could to estimate it because there is no information. That is nice and straightforward. Nobody ever claimed it was science-based. They didn't claim it was peer-reviewed. They were honest about their approach. So this one is kind of exceptional in that regard, that it's not quite so honest in its approach. But the upshot of this is, I did not update this paper because I'm a representative of the University of California, and University of California is supposed to be representing research-based scientific information. And I felt these plant lists were misleading because there was no research, no science-based research put behind them. There was research. It wasn't science-based. And I didn't publish my literature review basically that said this because I wasn't going to make any friends by doing this. Instead, Jim Bethke took some of these same ideas and published his literature review on it a couple years later. So you may be asking yourself, well, why worry about this stuff? I mean, who's going to really, if they're not science-based, who really believes them? And nobody would actually make this into law. Think again. There's a water parallel here. So back in let's see, how are we doing on time? We're doing okay. I'm wrapping up a little bit here. Back in the mid 1990s and 80s, a lot of people wanted information on what were the most water efficient plants out there. And the problem is that the question relies on a whole bunch of variables. What kind of soil have you put the plant in? Under what kind of heat regime? Is it in the coast? Is it in the interior valleys? Is it in the mountains? Different plants perform differently on different soils and in different environments. So it gets very complicated to make even a simple test to figure out what are the most water efficient plants, because water efficient under what conditions. So the way Larry Costello and Catherine Jones and a couple other people got through this was they convened expert panels, and the expert panels told them what they thought. And Larry was very upfront about the fact that this is not scientific research in a classic sense. It's more like sociology research, because what he was able to show was what people thought were the most water efficient plants. He knew it wasn't true science, but it was the best they could do under a fairly short time schedule with very little background information to work from. And he got lots of grief for it. People castigated Larry for not doing true science, but he's wearing a University of California hat. And Larry was very honest about that. He even put a legal disclaimer, and this is the disclaimer straight from his thing that says, basically, you will not use this to create laws. You will not use this to sue people. You will not take this to court. This is people's best guesses. He was upfront about this. And what did they do with this? You can guess. They created, this is not Larry's disclaimer. This is the California Code of Regulations. This is the law that they created, mandating that you follow this list that Larry said in the front page. Don't use this to make laws with. We are headed that way with fire safe plant lists. There are a bunch of people who are trying to push through things in Sacramento that say you may not plant Italian cypress in front of your house because it's a fire hazard. And the bottom line is they don't know it's a fire hazard. They've been out on fires, yes. They've watched them burn intensely, yes. But why do people plant Italian cypresses? People plant Italian cypresses because they want a tall hedging plant that blocks their neighbors or blocks the sound, and they don't want to have to take care of it. They don't want to water it. They can just put it in the ground. It'll grow year after year, and they don't have to clean it. They don't do anything with it. So how do you know that that 40-year-old Italian cypress is burning because it's underwatered and hasn't been maintained over the past 40 years, or because it's an Italian cypress? If you cleaned it and water it, would it burn differently? Nobody knows the answer to that. And yet they're banning them because they don't want to have to do work to figure this out. And I don't blame them. The fire departments don't want to drive into a fire trap. I don't blame them one bit. So it could be a self-fulfilling prophecy that when the fire department looks at your house and sees all these Italian cypresses lining your driveway, they're like, I'm not driving into that. It's a death trap, right? It may, even if you've taken perfect care of those cypresses, your house is going to burn because the firefighter's perception of it is that they can't be there safely. So that's why your house is going to burn. It's a self-fulfilling prophecy. I'm not trying to castigate the firefighters either. I wouldn't want to drive my fire engine down a driveway that nobody had taken care of those cypresses. They were drought stressed. If those cypresses are going to burst into flames, I don't want to be trying to get out to that driveway. So, you know what? It's a complicated question, and it's one we're going to have to deal with. And I'm not saying there is no basis for some of the things they're concerned about. I'd be worried too. The problem is it's just not as simple as a checklist about saying it's this and therefore that's going to happen. It's really about maintenance and teaching people how to take care of their plants. And it should not be about bickering about whether rosemary in your stone planter is going to burn your house down, or banning baccaris or anything else from your landscape. They're false senses of security because they sidestep the real issue is, which is you're not taking care of the plants in your yard. If you take care of the plants in your yard, it could look like this. This is what people are hoping to aim for, right? This is what survival looks like. Everything around them burned and their house survived brilliantly. That's not what's happening in most of Sonoma County. What's happening in most of Sonoma County, and this is taken from Sonoma County, is this. Their landscape breaks a bunch of the fire safe landscaping rules. Look, they've got continuous vegetation right up to the house, but they have taken care of it. Look how clean the ground is underneath them. They're watered, they're pruned. There's no deadwood in these things. So why is the house burning? The house is burning because the problem isn't the landscape. The problem is the house itself. They didn't clean the gutters, for instance, in the house. So people keep blaming the landscape. Yes, landscape can make a difference in whether or not your house burns. But if the house itself is the problem, the landscape makes absolutely no difference. You need to, before anybody worries about one bit about the landscape, they need to take care of their house. You need to have the gutters clean. You need to have your vents taken care of. You have to have a fireproof roof. You have to have, there are a ton of things that have to be done with the house because it's the house that's the first problem, the foremost problem, not the plants in the landscape. The plants can make a difference, but they're not the first thing to worry about. And I think this this picture captures it all right there. And this is what you saw in Paradise. This is what you saw in Lake County. It was the houses that were burning, not the land. Okay. There are some landscapes you probably don't want right next to your house. Greasewood, chamise, they're probably not great things to have planted right next to your house. Those are those 2% of plants that are going to burn fiercely and ferociously, even if you do try to take good care of them, because that's what they're ecologically designed. Design is not a safe word. That's what they're ecologically evolved to do. And there are other situations. This is a picture from Point Reyes after the Vision Fire. This is a nightmare. If you have a house that's near this, you've got a serious problem. Is it because it's knobcone pine? Well, in part, yeah, because knobcone pine generates very thickly, like dog hair thickets, dense, after fires. And that's what it looks like. But this is also, and I'm sorry, not knobcone, bishop pine. This is also a bishop pine. And it's fine. Look, you're gonna have to really try to set that tree on fire, because it's about the community. It's about how much dry wood and everything is around it that's contributing to the flammability. So if you want to do something about you need to avoid this situation. You need to have separation. You need to have irrigation. You need to have things clean. You want it to look kind of like a vineyard. You don't want it to look like this. Neglect is a problem. This, with separation and irrigation, is fine. It's the same species of plant. It's not about plant species. Okay. Okay. So, and that's all this was. That's what I'm really taking away from this web page from Idaho, Fire Safe Idaho, is really they're kind of making my case for me. If you take California fescue, it can fit almost anywhere on this graph, depending upon how you take care of it. So I just want to sort of a last few points. I want to point out that even for plants, it's about a community. So by day, plants actively manage their water, particularly California natives, because they had to in order to survive. So they're ecologically adapted to manage water. Let's see how we're doing. Okay, 15 minutes still, we're good. By day, it was all like we learned in school. The roots take up water, they move it to the leaves evapotranspirate, they make sugars through photosynthesis, yada, yada, yada. But what we never really learned is at night, what happens? Well, the plants are still taking up water, but now they're redistributing that water out to fungi in the soil called mycorrhizae, and the fungi are using that sugar water supplied by the plants to digest things in the environment, whether it's dead bugs, dead leaves, or just the soil itself to get phosphorus out of it. And they're reabsorbing that when the sun comes up and sending it out to the plant. In return, the plant is feeding these things sugars. So really, the plant is part of a community, and that whole
Stephen, you just cut out for me. I'm not sure if that happened for other people.
These communities all evolve to, or they all adapt to a routine. If you give them regular water, they'll get adapted to regular water. If you starve these communities for water, and then all of a sudden, oh, the fire's coming, and you decide to just drench them, they're not going to take it up. They're not evolved for taking, they're not adapted to taking up that much water within a single time frame. So you train your garden, if you will. The communities learn from how you do this. And if you expect them to, you've taught them their whole lives, they have to eke by on minimal amounts of water, and then you expect them to all of a sudden plump up the moment you add a ton of it, they're not going to do it. They're not trained to do it. So your landscape learns. It doesn't learn in a way that we think of thought-wise. It learns in an adaptive way. And we need to understand that we're dealing with a complex system when we plant and manage our landscapes. That means we don't just strip them of vegetation, because that's going to allow a bunch of weeds that aren't really a good community to come back. And now we're going to have to fight weeds next time when we have to deal with fire. So that is not the correct way of going about it. Similarly, when we're talking about communities and fire, I know this is getting a little way from plant lists, but you need your community. The biggest threat to your home in a situation like this is not those burning hills behind you. It's the clogged gutters in your neighbor's roof that is the biggest threat. Because when some little embers land on your roof, they're going to set your neighbor's house on fire. And when your neighbor's house burns, your house is going to burn. And if your neighbor is retired and on a pension and has no business being on a roof, and they have no money to pay somebody to clean their roof, then maybe it's going to be up to the community, and it's in the community's best interest to make sure those gutters are cleaned before the fire shows up. And I know we all like to think our home is our castle and it's just about us, but really we're members of a community, and we're all going to survive or burn together. And I know this is getting a tad preachy, so I'll try and rein that in. This is a community. It's gone. They all burn together. I'm sure some of these people have managed their house in a fire-safe manner. Some of them didn't. In summary, current fire-resistant plant lists are fiction. There are differences in species flammability. We know that, but we don't really know what they are. There are a lot of people's biases, and most people haven't taken the time to really sort out what is the function of species and simply what is the function of how we traditionally use those species in a landscape. You can use fire-safe plant lists if you want to. They're not going to hurt anything, but don't imagine that that will take care of important issues like whether or not your house is flammable. If your house is flammable, it doesn't matter what the heck you plant around it. So you have to take care of your house first. And that's far more important than some dumb plant list. So don't let the question of the list distract you from the important work in front of us. We all have work to do on our house, and we have work to do on our communities. And community is going to ultimately trump everything. Your garden community is going to trump how well your garden survives, and your social community is going to determine how well your house survives. These are the references I promised you, and I still managed to finish with 10 minutes for a few questions. And I'm sorry I'm emphatic and I rushed through a lot of this because there's a lot to say and there isn't much time. So with that, I'll shut up and take questions.
Stephen, people were typing in the chat furiously and I've recorded them. So I am going to go through from the ones I got first as quick as I can. So first off, can you take a step back and clarify what you mean by fire resistant versus fire resilient and fire wise? This person says, I've ended up removing plants that were considered fire wise because they made flammable leaf debris really hard to clean up. Maintenance is a key factor in deciding whether a plant is suitable for a fire wise garden. In this case in point is Arbutus unido is a nightmare. Who knew it would drop so many leaves that never rot? They still have to be cleaned up because they kill ground cover along with all the other leaf debris blown in, yet it's on the recommended tree plants.
So that's a great question. Thank you for asking that. So I would encourage you to pick plants to plant in your landscape that are going to be low maintenance. And there is no real difference between, there's no data to base these claims of fire resistant versus fire wise versus fire prone. There really isn't data to support any of these claims, which is my problem with the plant list in the first place. So what you have to ask is, what plants are you willing to put the work in? Plants on, say, for instance, typically in California, plants, big deciduous trees on the west side of your house are going to have huge carbon benefits in an urban environment because they're going to block sun from hitting your house in the summer. So it'll keep your heating bills down, and they can drop the temperature in your house by as much as 20 degrees. And in the winter, they'll drop their leaves, allow sun through, allow your heat to get some sun. The amount of carbon that tree sequesters is trivial compared to the amount of carbon you're burning when you're heating your house with electricity or coal. So those trees, if you want to, I mean, from a global perspective, those trees are critical in our work towards, because they're not just sequestering carbon on their own, but they're helping us save carbon intensive resources that we're burning to heat and cool our houses.
Stephen, that's fantastic. You're going to be leading an event about that next semester, aren't you? So if anybody wants to come back.
So I'm being too long-winded, but the bottom line is, if you're going to hear people say, oh, you got to cut off the leaves over the branches over your house. That's not true. What you do when you have a tree that's that big and it's over your house, you're just signing up to have to clean your gutters at least once a year, maybe twice a year, maybe 3 times a year, but you're getting a good benefit from it. You don't get the benefits of the tree without some cost. So yes, Arbutus unnato could be a pain in the butt. I'm not denying that. The question is it worth it to you to clean up after that Arbutus unnato? If it's not, then don't plant it. Ask yourself, what is this tree going to take? And yeah, the costs are not always obvious up front. I'll shut up now. What's another one?
Next one, I'd love to see tests with basement fuel moisture plus heat plus oxygenation plus warm airflow and use.
Low. Can't hear you.
Oh, you can't hear me? Can anyone else hear me? Everyone else can hear me. No? All right. I'm going to stick it in the chat for you, Stephen.
Okay, it just came back on.
Oh, great. Okay. Someone says, I'd love to see tests with basement fuel moisture plus heat plus oxygenation / warm airflow and using embers. Someone else said, can we discuss embers? Is it true 90% of houses burn from embers? According to my UCCE mentor, Kate Wilkins, she said we clear near the house so firefighters can get to the embers. So those are connected.
Yeah, this is a little bit out. So there's great questions and there's good information. Steve Quarles has done most of the work on this. Maybe we need to get Steve Quarles in to talk about home hardening and the research he's done. People have built houses inside of warehouses with controlled airflow and ember generators, and they blew embers at them until the house is burned. I mean, it's cool. Amazing research been done. So this is not coming out of things. Those estimates of 90%, I believe them most of the time. Okay, I bought a house not too long ago. I climbed up in the attic because I know that the big problems are typically when embers blow into the attic. What I found was people had remodeled that house 3 or 4 times. Nobody had ever cleaned up any of the drill sward from drilling through the walls. There was sawdust everywhere in my attic. And those vents that are directing those embers right into that attic, and then they settle out on those things. It's like, it's no wonder somebody's home burns, because they're pretty much, nobody's cleaned the inside of the attic. There's no screens on the thing. You want to make your house fireproof or more fireproof, put screens on your vents, make sure you have a good roof, and clean your attic, and make sure that those spaces that are don't have a bunch of sawdust in them. Sawdust is super flammable. So
there's a lot of good info in the chat here from people, lots of resources that people are sharing with each other, which is fantastic. So let me just say did you have something to say? Sorry.
No.
One person recommends videos by Jack Cohen on home hardening, who did thousands of hours of tests of different building structures. I don't know if you've heard.
Test with Steve Quarles, right? So Jack Cohen, Steve Quarles, they worked at the Insurance Institute for Business and Home Safety, IIBHS, in North Carolina. That's where they built some of these houses. They also did some in Richmond here in California.
We have design aspects, spacing versus plant species versus maintenance needs, which go way beyond watering. And this person's like, house first, and recommends working from the home outward, lessons from California for federal wildfire policy, which looks to be a great resource. And there's also a paper that is by UCCE and the Forest Service, housing arrangements and vegetation factors associated with single family home survival in the 2018 Camp Fire. Someone I know, Yana Valkovic, is on that article. So we have great resources in the chat, and I'm going to try and compile these and send these to everybody afterwards. It looks like we have a very knowledgeable crowd. There's somebody else who mentions Greg Rubin has presentations that address exactly the maintenance versus plant species issue. Don't know if you know Greg.
We do. Greg has some good things to say, and they're thought-provoking. I'm not sure I always agree with every conclusion he comes to, but he is certainly worth listening to.
There's also people saying, hey, one reason maybe these lists are out is because it's a lot harder to tell homeowners they have to clean up after themselves.
True. It's so much easier to just plant the right plant and forget about it. You're done. Right.
Maybe this has already been covered, but I'm wondering how to convey this information to local fire departments and jurisdictions who may not be educated about these issues. That's really important if we can take 30 seconds.
Well, we're in the process of doing just that by working in these fire safe Marin councils. One of the reasons I didn't publish this whole thing is the fire department pushed for the fire safe plant list in the first place, and then coming in and they got what they wanted. Somebody published something and then coming in and telling them that the thing that they had been lobbying for and had been delivered to them wasn't worth the paper it was printed on, wasn't going to be a well-received message. So we needed to talk about, and it hasn't entirely been well received. I won't tell you that every firefighter in Marin County thinks I'm a really great guy. And I tend to be a little bit forceful with my opinions, and that hasn't earned me anything, friends either. On the other hand, I believe in, if it's true, I'm happy to stand up for it. If it's just a bunch of hooey, then I believe in calling it a bunch of hooey.
Well, Stephen, people are saying in the chat, can we see more of your presentations? Can we get the link to this? People are literally sharing other presentations you've given through East Bay Chapter of CN, or through, I see another one, I can't even read it, but they're very excited about what you have to say, and we just can't get to all the questions. I'm so sorry. One person says a copy of this should be sent to local news stations because they're so excited by your talk. One person asked, do we really know about the fire safe zones with different landscape types? Maybe take a few seconds to answer that question. For example, fire safe zones. So for example, this person's on a ridge with chaparral below.
Right, those fire safe, well, so this gets it, there's at least good research behind this. There is still, we always get into these kinds of questions of debate. You can debate some of this. Some of this work is done with remote sensing data, and her name is Safard, Alexandra Safard. She's out of Los Angeles. She actually works for the insurance agencies. She's got some really intelligent, very thoughtful things to say about home loss and those defensible space zones. Safard's work has pretty much shown that after, that's where some of this data that says that 90% of homes are home ignitions are ember generated, and that's probably a moving target that you're looking at there. As a bunch of homes burn and they're built with better things, hopefully those numbers are going to change, especially as people get better about armoring their roof vents and their roofs themselves. So I'm really hoping that in the future, we will not be seeing numbers that high, which will shift this whole conversation, and this conversation is moving. So honestly, 2 years from now, hopefully we're not having this same talk. We're going to be talking about different issues, and things that we said today will not be true, because then maybe not all home ignitions will be ember generated. Maybe we'll have more direct flame contact. I know that sounds horrible, but in a world where we no longer have 90% of the home ignitions being caused by embers, that means our home ignitions have gone way down. So anyway,
can I do one last question?
Yeah.
Final question. What is the one thing that each of us could do to promote this knowledge to the average public? And one person actually says, share with neighbors, perhaps a little tips with photos. Finding that next door does a good job, though reach is smaller. So that was their suggestion, but do you have one thing each of us could do?
Each of us could, well, I mean, a little bit is lead by example. So especially if you have a contractor coming out, my neighbors anyway are very curious whenever I get a contractor out. First of all, it's a miracle you can get a contractor in this thing. So how'd you do that? the next thing is, what are you doing? Oh, we're having somebody, put in finer mesh netting on this because of the fire list. If leading by example, putting your money where your mouth is, instead of trying to tell somebody else what they need to be doing, but instead doing it yourself goes a long way toward helping other people get it, if you will.
This was such a lively discussion. I'm so sorry to have to keep it shorter, but Stephen does have his email up there if you are so moved. And again, please feel free to contact me. I'll put my email in the chat one more time. Thank you so much, Stephen. This was clearly a needed conversation. So I really appreciate you showing up today. We're excited for your event next spring. I want to tell you a little bit about things coming up that you might be excited about. So I'm also putting in the chat where you can find information about our upcoming events. This is only one of 18 events. So we have a lot of other exciting things this semester. Next Wednesday at noon is our first Building Resilience event. And that's part of a series. It's a year-long conversation to increase community collaboration on resilience to climate change. And there's topics from food security to disaster support to urban greening. And the first event will be on drought and flood in the Russian River watershed, featuring leaders from thought leaders on the campus and the community. Then Monday, October 18th is a special event led by local soundscape ecologist Bernie Krause. And that one's called Local Nature, Power of Tranquility in a Noisy World. And the reason to come to that one live is it's not recorded due to copyright. So you should take advantage of it while you can. It's going to talk about our current thinking about our sonic world and how we can all become active participants in mitigating noise pollution, basically. So lastly, if you are a professor or a high school teacher or instructor, I highly encourage you to take a look at Live from the Field, Freshwater Invasions. And that is an event taking place in October, I think it's the 25th. And these Live from the Field events were designed during the pandemic to give students, like full classes of students, virtual field experiences. They incorporate into course curriculum. We have materials for you, pre-reading, post assignments, and it really fits in with the standards. And you can use them instead of guest lectures. So it's an NSF grant. It's really full. So please take a look at the virtual field event coming up. And as a reminder, this is recorded. All of our virtual events are recorded. They're posted online. So I know people have been asking how to share this. It will be posted on the event page. And I'll also be sending a link via email in a week or so after that's up and after we've compiled all these resources for you all. Let's make sure there's no other questions that need to be addressed right now. Carrie, is there a link to the Live from the Field events? Yes, so if you go to the calendar page that I just stuck in the chat and you go to October 25th, it's right there. It's all in date order. Everything else, you can email me with questions, follow up. And just so many thank yous coming in, Stephen. It's critical to get this information out. People are planning on sharing this. So thank you again. Everyone, have a fantastic rest of your day.